Hi there, my name is Muhammad Haziq bin Sazali and my partner is Muhammad Danish Aiman bin Muhammad Nazir. Today, we will be presenting our project titled Smart Stray Animal Feeder. This is an IoT-based solution designed to help care for stray animals, specifically stray cats, in urban areas like our USM campus. Let's begin with an overview of the system. The problem that we are trying to address is the large number of stray cats in Penang and on our campus. Currently, feeding depends entirely on people or volunteers, which means it's inconsistent. There's no feeding at night, during weekends, or during semester breaks. Also, rain disrupts feeding, and there's no way to track how much food is actually consumed. Plus, manual feeding can lead to food wastage and affect cleanliness. We wanted to solve this with technology. Therefore, our solution is the Smart Stray Animal Feeder, an IoT-enabled device that automates the feeding process. It uses PIR sensors to detect animals and automatically dispenses food. It can be monitored and controlled remotely through a web dashboard. It also has rain detection to protect the food, tracks all feeding events, and can scale to multiple devices across all locations. Also, it will alert us when the food or water is low. Moving on is the project architecture. Our system follows a 5-layer IoT architecture. At the bottom is the perception layer with our microfeather ESP32 microcontroller, sensors like the PIR motion sensor, load cell for weight, rain sensor, and water fluid sensor. The actuator is servo motors for dispensing and also a manual button. In the network layer, it uses Wi-Fi and MQTT protocol to communicate with our cloud, while in the processing layer, it runs on Google Cloud Platform with a Mosquito MQTT broker and a Supabase database. The application layer is our Next.js dashboard for monitoring and control, and lastly on the top is the business layer, where it provides analytics, reporting, and also alert notifications. Now, let's proceed with the demonstration. Here is an overall view of the prototype. Now, let's proceed with the demonstration. Now, let me demonstrate every part in more detail. When I place my hand near the PIR sensor to simulate an animal, you can see the servo motor activates and dispenses the food. The sensor has detected motion and triggered the dispensing automatically. I can also press the manual button here and the servo will activate again. This is useful for people who wants to dispense the food manually. You can also see in the image on the right here, the load cell is measuring the food weight, and all of this data is being sent to our cloud through MQTT. Another way is through remote command. By clicking the dispense food button on the dashboard, the servo will activate in real time. Next, for water dispensing, when I place my hand near the PIR sensor, the servo motor will activate and dispense the water. We can also press the manual button here to dispense the water. Similar to the food, we can also use remote command by clicking the dispense water button on the web dashboard to dispense the water in real time. Next, when it rains, the rain sensor will detect the rain and will change the status on the dashboard from dry to raining and will restrict from any food and water dispensing. Next, when it rains, furthermore, a water float sensor is used to measure the water level for refills and allows water dispensing only when water level is at a specified level. Finally, here is the full view of the working prototype. As you can see, when I place my hand in front of the PIR sensor, the servo motor will activate for food dispensing. Similarly, goes to the water dispensing, and on top here is the rain sensor as well as the water float sensor inside the water tank.
So this is the dashboard for our smart stray animal feeder. And in here we can see the current device status. Now it is online. And we can see the food level, 230 grams for the current device, and water level is still okay. Water tank has water. Also we can see the current weather for the current device. Now it is dry and not raining. And the total dispense event for the device. Can also access the remote control to control the dispense food and dispense water for the device. And we can also see the device locations here total. We are just using dummy data here. And we can click on the location to access other device. Now it is feeder 3, and if a device is offline, we cannot access the remote control. So for statistic here, we can see the total food event, total water event, and the weight of food that has been dispensed for the current device and for all of the devices by daily and weekly. You can also see the animal activity here for the past 7 days, and we can see graph for the food weight history for the past 24 hours. And we can see that food has been dispensed successfully for this device and also for all devices. You can also see the recent dispense event to see the amount of food the amount of food and water that has been dispensed. If we click all, we can see which device has dispensed food and water. So we can also set the current device location and change the location name and save the changes. Device setting has been saved, and the location will also be updated in the maps. And we also have a function to send notification when food level is low, below a certain threshold, which we can set here, and when the water level is empty, or either when the device goes offline. So that is all for the data visualization and our dashboard for smart animal feeder. Thank you. So
Moving on, our project aligns and give an impact to the UN Sustainable Development Goal number 11, Sustainable Cities and Communities, because we promote inclusive urbanization by caring for stray animals. And then, our automated system reduces food waste through precise dispensing. Furthermore, well-fed strays are healthier and usually less aggressive, making public spaces a lot safer. And with all the data that we collect, we can support evidence-based policies for more animal welfare. The system is also designed to scale from a single feeder to campus-wide or even for city-wide deployment. And that will be all from me, Haziq S, and also Danish Aiman for our project Smart Stray Animal Feeder. Thank you very much.